So if you're still having trouble figuring out these sides, let's see if we can help just a little bit. So bottom line, we have this angle theta, and it is said that the best place to sit would be a place where that angle is the largest. So you want this viewing angle theta to be the maximum. So what we want to do is be able to express theta in terms of x, the position you'd be sitting, and then we could find y. So how we're going to do that is we're going to try and get these two sides of the triangle that theta's in and use the law of cosines. But to do those, we've added these other lines in so we can figure things out. Here we have the point xy, so we could get things in terms of x and y and ultimately in terms of x. So a couple of things. We know that this is 20 and then this is x, but this triangle right here is an isosceles triangle because if this is 45, this is 45, since this is a 90. So whatever this measures, this side measures the same thing. Well, this total length is x, and if we subtract off this piece, which is 20, we would have the length right here, x minus 20. And whatever that is, this is the same, x minus 20. That's also our y value, so that also equals y. Now, if we looked at this leg of the triangle, this full length was 60, and then if we subtract off the y value, we will have the length of this leg. So this particular one right here is going to be 60 minus y, but we want things in terms of x, but here is our connection. So we could do 60 minus x minus a minus, make it plus 20, and so this would also equal 80 minus x. Now this side right here is just x, and if we looked at this whole triangle here, this green one, that whole side is also just x. So what we want to do is use the two legs. We've got them for the red triangle. This side is x, this side is 80 minus x, and use the Pythagorean theorem to find this length right here. We'll call it L1. So that should be easy enough to do. L1 is going to be x squared plus 80 minus x squared square rooted, because we got a squared plus b squared equals c squared, but we did the square root, so we didn't have it squared. So there's the hypotenuse of the red triangle. Now we can do the same thing with the green triangle. So this whole side is x. This side is x minus 20, so we could do this leg squared plus this leg squared square rooted would equal this hypotenuse and give us the L2. So I'm going to let you finish that part. But bottom line, once we have those two lengths, then we can use the law of cosines to write an expression for theta. And so if you remember the law of cosines from trig, it basically says, so we're going to go with the side opposite the angle we want to know, that's 60, and so it says one of the sides squared equals the sum of each of the other sides, which is L1 squared plus L sub 2 squared, minus 2 times the product of those sides times the cosine of the angle between those two sides. So here is the law of cosines. You can sub in the values you get for L1 and L2, and they're kind of big and ugly, so it's okay to use them as L1 and L2 until you absolutely need to. So you could solve this for theta. You could move these two terms over, divide by this stuff, and have cosine theta, and then theta would equal cosine inverse of whatever you get, this big thing, and that's what I'm calling A when we go to work it, but you need to tell me what that A is. So it would be from solving this for theta.